In the vast expanse of the ocean, nothing rivals the sheer power and ingenuity of the U.S. Navy aircraft carriers. Also referred to as floating cities, or cities at sea, these giant machines are capable of launching fighter jets at supersonic speeds and are powered by a nuclear heart that never sleeps. With the power to carpet an entire country in a matter of minutes, these engineering marvels stand as the ultimate symbols of dominance, enduring the relentless forces of nature by operating in the most unforgiving environments on Earth. This is not a work of science fiction, but a reality of the insane engineering of aircraft carriers. There is a lot more to aircraft carriers than just their enormous size. Each aircraft carrier in its own right is a symbol of power, innovation, and dominance. These floating giants are a testament of engineering brilliance, carrying thousands of sailors, pilots, and crew members, all working in a perfect symphony. However, not all aircraft carriers are made equally, and by far no country, including China and Russia, has been able to overtake the US as far as technological advancement is concerned. These giant carriers are mainly why China hasn't succeeded in its ambition in the South China Sea and with Taiwan. The US's interests in the Middle East and South African countries also remain secured despite the volatile politics in that region. And perhaps, most importantly, we have been able to keep Russia at bay and hinder its objectives in Eastern Europe. We hope we have your attention because, in this video, we'll uncover the incredible engineering behind these colossal machines. We'll see how these 100,000-ton giants stay afloat in fierce oceans while carrying dozens of fighter jets. Where do they get the electricity to power thousands of onboard systems? How does an intricate catapult system launch the 70,000-pound fighter jets faster than a Formula One car? And perhaps, most importantly, how do they defend against the growing threat of cyber attacks from rivals like China and Russia? We will explore the ingenious nuclear reactors which power these carriers, enabling them to operate for decades without refueling. We will also dwell into the high-tech radar systems that allow the carriers to intercept the threats from thousands of miles away. The immense human efforts it takes to build, maintain, and operate these masterpieces are often overshadowed by the technological aspects of these beasts, but they deserve recognition, and we'll shed light on that too. By the end of this video, you'll understand exactly why the US Navy aircraft carriers are insanely well designed and what makes them the most feared symbols of power. Part 1. The colossal scale and purpose of aircraft carriers. Most carriers in the US Navy, such as Gerald R. Ford class and Nimitz class, are over 1,000 feet long, almost as long as the Eiffel Tower lying on its side. The typical flight deck takes about 250 feet, providing an enormous area equivalent to 4 soccer pitches. Their height, measured from the keel to the top of the mast, measures about 20 stories tall, and most of it is hidden below the water level. A ship of this size displaces about 100,000 tons of water, making them just as heavy as an average skyscraper. Chinese and Russian flagship aircraft carriers seem a bit compact compared to their US counterparts, weighing around 50,000 to 70,000 tons. While it might not look much of a difference on the paper, in reality, it affects almost every aspect of combat operations. All that said, it is not the size but what it is packed with that makes them a symbol of terror. The enormous size of the aircraft seems compact when you look at the arsenal it carries on board. As we begin to go into the details, you will realize why such a massive size is needed in the first place. For starters, the fundamental purpose of an aircraft carrier is to act as a floating air base. While the Air Force can scramble dozens of jets in a matter of minutes thanks to the abundance of land, the Navy doesn't have that luxury. It has pulled off almost the same job with the airstrip that is minuscule compared to Air Force runway. But despite that, it executes it perfectly. It is because of the vast flight deck which provides space for launching and recovering aircrafts. The large hangar sitting just below the deck is essential for storing and maintaining dozens of aircrafts. If the aircrafts are not up to the scale, it would become impossible to operate, service, and house a fleet of about 90 jets efficiently. This is in contrast to Russian and Chinese aircraft carriers, which can house a fleet of 50 jets at max, cutting their operational capabilities down by half. Furthermore, as mentioned earlier, aircraft carriers are home to more than 5,000 sailors, pilots, engineers, and support staff. Each of these individuals needs a living space, a place to dine in, medical services, and recreational areas to sustain months and sometimes year-long deployments. The enormous size of the carrier is enabling the integration of necessary amenities without compromising operational capabilities. In addition to easing day-to-day aircraft operations, the large design of the aircraft carriers also plays a key role in battling the rough seas. The enormous size makes the ship stable in the rough sea, allowing it to cruise smoothly even in storms. Also, it enables robust armor and compartmentalization, making the ship extremely resilient in combat scenarios. The USS Nimitz is a classical example of such a design, which can function at 100% as a warship, even when some of its parts get damaged in combat. Lastly, the giant size of the carriers makes them visible and an unmistakable symbol of US military strength. Their presence alone serves as a deterrent, project power, and influence without even needing to engage in combat. Part 2. Staying afloat. The engineering for stability and strength. We have mentioned the size of an aircraft carrier helps it stay afloat, but it's a fairly simple explanation, and there is actually a lot more to it. Aircraft carriers like USS Nimitz rely on vital structural and design principles to ensure they not only survive, but thrive in the harshest environments on our planet. The double hull structure is the first line of defense, consisting of 2 layers of high-strength steel at the exterior of the ship. This layer absorbs, deflects damage, whether it's from the collision of rogue waves or the torpedoes from a hostile submarine. The inner layer works as a cushion and absorbs the impact without transferring it to the rest of the ship. Between the 2 layers, there is a vast space divided into several subspaces, which form hundreds of watertight compartments. While cruising through the enormous waves, the compartments can be filled with water to maintain the balance. Such a design ensures that even if one part of a ship sustains damage or flooding, the rest of the carrier remains operational in both peace and combat operations. The Chinese flagships, including Liaoning and Shandong aircraft carriers, are built with single or semi-double hulls, which is not as sturdy and strong as a double-hull design, giving the US carriers a massive edge in combat. Furthermore, the number of flooding compartments is also rather low, which limits the ship's balancing capabilities and also increases the risk of sinking during combat. Another feature vital to the stability and efficiency of aircraft carriers is the hull's bulbous bow, which is a protruding structure right beneath the waterline. It alters the flow of water around the hull to reduce wave resistance and drag. This makes the ship fuel efficient while simultaneously enhancing the ship's abilities to cut through the waves, minimizing the impact of large waves on the flight operations. While the design of aircraft carriers is fascinating, the construction process of these giants is equally astonishing. USS Gerald R. Ford and other modern aircraft carriers are built using modular techniques, which essentially means that these ships are made by integrating massive prefabricated sections, each weighing thousands of tons. Each section carries its own assembly of complex wiring, plumbing, and ventilation systems. The process of integrating these huge and complex pieces together is a work of art, which deserves a video of its own. For now, let's move to an even more interesting section. Part 3. The heart of the carrier. Nuclear propulsion. Nuclear reactor is a technological marvel that lies at the heart of every US aircraft carrier. It not only powers the engine that propels the ship across unending oceans, but also supplies electricity to every piece of electronics on board. Whereas the conventional ships rely on fossil fuels, the combat carriers cannot have that limitation. These carriers often have to sail from one part of the world to another in a matter of days, and they cannot just stop at the shores of different countries to have their tanks refilled. It exposes the carriers to unwanted threats and causes a load of inconvenience in the operations, but engineers have found a fix for that. Modern aircraft carriers like USS Gerald R. Ford and its counterparts feature a nuclear reactor, allowing them near limitless range, endurance, and making them an icon of naval dominance. And it is by far the most vital technological advantage that the US has over Russian and Chinese aircraft carriers. Take the A-1B reactor of the USS Gerald R. Ford, for example, the latest class of US carrier. Its advanced system uses enriched uranium to produce heat through nuclear fission, which is then transferred to the secondary system to convert the water into steam. The steam drives the massive turbine, which powers the ship's propulsion and the array of systems including radars, weapons, and the much-talked-about catapult system used to launch the jets. While the nuclear plant makes the ship invincible, it has to be managed delicately to prevent major catastrophe, which can be fatal to the thousands of personnel on board. A team of highly competent engineers monitor the system round the clock and assess them continuously. Metrics like temperature, pressure, and radiation levels are checked continuously to operate the reactor within safe parameters. An astonishing fact of this whole system is that once it is up and running, it can easily last up to 20 to 25 years, allowing the carriers to be deployed for decades without ever needing to refuel. This logistical independence allows the US Navy to project its power anywhere around the world at any given time. Part 4. Launching and landing at aircraft carriers. We all know the primary function of an aircraft carrier, which is to launch and retrieve fighter jets in the middle of the ocean. Modern aircraft carriers demand advanced and sophisticated technologies to safely accelerate the jets to the takeoff speed within mere seconds. Like everything else, the US Navy has come a long way in that as well. Previously, the Navy used traditional steam-powered catapults to generate violent and high-pressure force, which, while effective at providing the jets with necessary acceleration, also contributed a lot to the wear and tear. In contrast, modern aircraft carriers now use electromagnetic aircraft launch systems, or EMALS. Unlike the traditional catapult systems, EMALS rely on electromagnetic force to provide the aircraft with necessary acceleration. The system uses a series of linear motors that have the current passing through them to generate a magnetic field. This magnetic field propels the aircraft along the track, but in a more efficient and lighter manner than traditional steam catapult. This process is also gentler on aircrafts, thus reducing the wear and tear of the jets, contributing to their longevity. Retrieving the jet is also just as complex. Aircrafts have to rely on a tailhook, which is a reinforced hook on the plane's fuselage designed to catch a resting wire. The arresting wires are made of steel and stretched across the deck to absorb the enormous force of the plane's landing. Once the aircraft is attached with these wires, it decelerates almost instantly, ensuring it safely stops in a short distance, often within less than 300 feet. Like the catapult, the arresting gear is also incredibly robust and capable of handling most modern jets like FA-18 Super Hornet. Combat demands operations to be precise and fast, and this system ensures that regardless of the conditions. Despite landing dozens of aircrafts daily, the system remains durable and incredibly resilient. In contrast, the Chinese carriers use a ski jump ramp to launch aircrafts wherein the jets rely on their own thrust for takeoff, which is assisted by ramp's incline. Such a system is much cheaper and simpler than the one used in US carriers, but it also limits the type of aircrafts that can land and take off, thus compromising operational capabilities. The launch and landing of every aircraft takes a coordinated effort. During the operations, flight deck is the busiest and most dangerous place on the entire carrier. To avoid any accident and smooth operation, the deck personnel are divided into specialized teams, from those handling the jets to those who guide them into position. Each crew is led by a flight deck officer, also known as FDO. FDO is in charge of all the aspects of landing and launching the aircraft. Then there is an aircraft handling officer who works closely with the FDO, but the job primarily involves managing the aircraft on deck. Parking of the plane, alignment with the catapult, and positioning for the recovery are some of the key parts of their job. Similarly, catapult officers, also known as shooters, are responsible for the launch of the jet, while arresting gear officers are tasked with the landing of the jet. While these are some of the important roles, there are dozens of other individuals who take part in the whole operation, including landing signal officers, crash and salvage team, plane directors, aircraft handling crew, and safety officers, among others. Communication holds the utmost importance, and it is the responsibility of the air traffic controllers to ensure a seamless teamwork between flight crews, deck officers. They also have to be precise and seamless to ensure there is no undue delay between landing and takeoff of the aircraft. The combination of EMALS for launch, arresting gear for landing, and the dedicated team to ensure every system works perfectly Aircraft carriers function like a well-oiled machine, ready to unleash havoc on the enemy. Part 5. The command and control. While the size and the modern aircrafts are crucial to the carriers, the true power lies in its ability to command and control. It is the heart of operations and often termed as Combat Information Center, or CIC. A team of highly trained individuals reside in the control center and monitor every aspect of the carriers 24/7, from the radar systems to communication systems, from the weapon control to analysis of recon aircrafts. Everything goes on in this place. The Spy-3 radar is at the core of this system. It is one of the most powerful and advanced radars in the whole world, capable of detecting and tracking multiple airborne, surface, and subsurface threats up to 200 miles away. Such an advanced tracking system allows the carrier to anticipate threats early and enables a swift response. This radar is also a critical part of anti-air warfare, helping the carrier to detect drones, missiles, and aircrafts from miles away, which is then communicated to the fleet group so an appropriate action could be taken. Another impressive feature of the CIC is the Cooperative Engagement Capability, CEC, which allows the carriers like USS Gerald R. Ford and its task force to operate as one unit. This technology seamlessly integrates carriers with the aircrafts and other ships in the strike group for maximum efficiency. The information being processed at the CIC is shared with the entire fleet in real time, allowing the strike group to control a large operational area to ensure no threat goes unnoticed. The USS Enterprise CVN-6, Navy's first nuclear-powered carrier, pioneered this system and shaped the role of a modern aircraft carrier as the command post. During its service, the Navy realized how a carrier can be evolved from just a hub for launching and retrieving aircrafts to sophisticated hub of naval strategy, which integrates all communication systems and real-time battle management. Modern aircraft carriers have taken this concept miles ahead by incorporating artificial intelligence and automated decision-making processes, which allow the commander to make the life-or-death decision in just seconds. However, using a system like that also exposes the aircraft carriers to modern, untraceable, yet most effective threats like cyber attacks. Part 6. Cybersecurity. Defending the digital fortress. While physical security has been ensured by the Navy, it has poured just as much resources in managing the cybersecurity of the carriers as well. The US Navy realizes that cyber attacks are the new torpedo, and just like the actual torpedo, they can also bring the whole fleet down. Thus, the need for an effective defense against cyber threat is paramount to ensure the security of every aspect of the carrier's mission. Modern aircraft carriers feature cutting-edge technology when it comes to cyber defense. These systems are designed to detect and mitigate threats before they can cause any harm. Each strike group has a multi-layered cybersecurity, from onboard firewalls to intrusion detection systems. The communication carried out between inter- and intra-ships features multiple-layer encryption, so even if a hostile reconnaissance drone or aircraft captures it, there is no real threat, because breaking that encryption is next to impossible. Each aircraft carrier has a dedicated team of cybersecurity officers to ensure every device that is connected to a network, from the communication system to the mobile devices of the sailor, is secure. The team constantly monitors every system to detect unauthorized intrusion and block it at the moment of the detection. Furthermore, the team routinely holds drills and simulation to train the individual's real-time threat management. So if the ship is ever attacked, the team is well prepared to fend it off. The US Navy also works with other branches of military and cybersecurity agencies like NSA to share and collect intelligence about the new threat and coordinate with them to develop the mitigating strategies. The ultimate goal is to develop a unified cyber defense network that spans the entire fleet, protecting not just an individual fleet, but also the larger naval force as a whole. Perhaps the biggest challenge in the whole exercise is to keep the communication channel operational. Whether it is to communicate with the other ships in the fleet or with the aircraft in the sky, every aspect of the aircraft carrier depends on it. So, if these channels are compromised, bringing the whole fleet down is not much of a challenge for the hostile countries. Thus, the encryption technologies are constantly updated to stay at the top of the global threats and to maintain the security of the naval fleet in the growing danger of cyber attacks from hostile countries across the globe. Conclusion: the pinnacle of engineering and power. From the colossal size to the baffling technologies that power them, U.S. aircraft carriers are a true marvel of modern engineering. These are not just ships, but self-sustained and thriving fortresses with enough power to bring any regime to its knees. Whether it is the vastness of their hull or the power they sail through the harshest environment on the Earth without compromising operational capabilities, these giants do not disappoint. We are doing a whole series of episodes on the design and engineering of aircraft carriers, fighter jets, and hypersonic missiles. So, stay tuned for fascinating insights into the naval and military technology and global defense strategies. Let us know your ideas in the comments.